So I'm actually recording this at the same time that I've been making the cell nav videos because I had forgotten about this and the next video I'm going to make until just now, but it should fit in well with the set and drift problems. So Leeway is almost identical to set and drift in concept. The only difference is set and drift are the result of current, whereas leeway is the result of wind, which is why you've got lee in there, the leeward side versus the windward side, stuff like that. You could define it as the direction that the ship is pushed towards the leeward side by the wind. Therefore, just like with current, if the current's coming from down here and you're on this course, you get pushed this way. Well, the same is true as if there is a wind coming from here, it's going to push you offset just as much. The calculations are different. You have a different technique for determining leeway. Luckily, it's an easier technique. It's actually very simple. So the way a problem like this would be constructed is you would be asked the question. It would say you're on course, just do 150. Wind is coming from the north, causing 4 degrees of leeway. It would ask you what is the course made good and what is the course to steer. So what this is saying is obviously you're on course 150 and the wind, it wouldn't say coming from the north, it would say northerly wind, because that would then test you. You would have to be able to recognize that means it's coming from the north, because a current is described by the direction it's going. Wind is described by the direction it's coming from. So a northern current goes north and a northerly wind comes from the north. So we'll say wind northerly. So a wind coming up from the north is pushing you off course by 4 degrees. The way you work this out, you can do it multiple different ways, but the way I like it is first you just draw a basic little compass and you place your course down. So we're on course 150, that'd be about there. Okay, the wind, then you draw the wind. The wind is northerly. So just draw it like that. It's just generally going in this direction. So if the wind is going this way, how would it push an object that's headed in this direction? It would push them down. Here's the lever. Hit it here, so it would actually push you in that direction. Makes relatively good sense. And however much it pushes you is 4 degrees. So you would apply 4 degrees in this direction that you've determined, and you would get a course made good of 154. Now, if you wanted to fight the wind, if you wanted to push up against it, you would just apply the same amount in the opposite direction. 4 degrees, nice and easy. Your course to steer would be 146. Not that hard to do. Let's try another one. Let's say you're on course 330. Wind is southwesterly, causing 3 degrees of leeway. Usually leeway will be something from 0 to 5 degrees. Not a guarantee, but that's just what I've always seen the questions written as. So then again, course made good, course to steer. So you draw your compass, place your course first. So there's 330. The wind is coming from the southwest because it's southwesterly. Which way is that going to push you? It's going to push you in this direction, 3 degrees. It's going to add 3 degrees, 333. You're going to fight it 3 degrees to get your course to steer. That would get you 327. Obviously, you won't always be pushed in a clockwise direction. That's just the one I chose. So I guess real quick, if we did it, this was your course. and this was your wind. Let's say that's what, 240, and the wind is like 2 degrees. Then you would get a course made good of 238 and a course to steer of 242. So this isn't complicated to get. It really is very simple. One thing I'd like to add at the end here, something I haven't talked about before, is crabbing. So it's important to note that while you're being offset by the wind or the current onto this new course line, doesn't mean your ship is facing that way. So if this is your ship on this proper course line, you're not necessarily facing this way once you've been pushed off of course, either by the wind or the current. This applies to both of them. Technically, you would still be probably facing the exact same direction you have been, just gliding off to the side diagonally like this. That's called crabbing or crab walking. This is especially true for set and drift. Wind is actually, there's a strong chance that you'd be facing somewhere this way. So if the wind is coming from here, you might actually lean into it like this a bit and then continue to glide off diagonally. And the reason that is because when a ship is headed, when a ship is making way through the water, actually we'll start with this. When the ship is dead in the water, its pivot point, so the point that it turns around, is right in the center. If a ship, however, is making way forward, the pivot point moves to the front, and it moves further forward if you're accelerating. If you've stopped accelerating but you're still making way forward, your pivot point is going to be somewhere towards the bow. If it moves aft, it's going to be somewhere after the bow. And what that means, if your pivot point is up here, is if the wind comes to you from one side, you have more lever arm back here than you do up here. So it's actually going to push you more on this side, which is going to swing you towards the wind. And if, let's say, you were going aft, then there would be more lever arm up forward, and that would swing you away. But the majority of the time, you'll actually have your heading turn in towards the wind while you get set, or while you get pushed from the leeway off to the side, which is called crab walking. Meaning, this is your original course, and you're headed this way. The wind comes in from here, you will end up facing this way and moving off in this direction. So you have to fight both at once.